All right, today we'll talk about similar polygons, but before we do that, let's refresh our memory on what we did a couple chapters ago with congruent figures. Doesn't that mean that they're same size, same shape, right? Congruent to each other? Well, today is similar. So there are lots of things in this world that are similar to each other. In our own words, they'd be the same shape, but like different sizes, right? Similar figures are the same shape, but different sizes. So here's some examples, like a model car, right? So I don't know if you've ever seen model cars before, if you like to build them, this, that, or the other, but this right here is a model car of a 1966 Chevy Nova. It is the same shape of a 1966 Chevy Nova, but it is not the same size. Wouldn't that be ridiculous for it to be the same size as a 1966 Chevy Nova? So these guys are similar to each other. There's two rules, right, to be similar. That all the corresponding angles have to be congruent to each other, and all the corresponding sides have to be proportional. Here's an even better example of similar figures. This is a map of Kansas. Should a map of Kansas be the same shape as Kansas? Yes or no? Yes. Should it be the same size as Kansas? That would be ridiculous to have a map that is the same size as the state of Kansas. How would you fold it up? I mean, it would just cover the entire state if you unfolded that thing. That would be nonsense, right? So do you think that all the angles that go together should be congruent to each other? Like these crazy angles here in the old state where the river goes through right there, shouldn't those be pretty darn exact to what really is happening in real life? Now, everybody knows because it's a river, like they'll change a little bit here and there, but shouldn't this angle be the same as what it really is between all the borders in real life and et cetera? If this is a 1966 Nova, shouldn't whatever curve that this fender makes be exactly the same as what the curvature on that fender is in real life, and et cetera, et cetera, et cetera? You get what I'm saying about the angles that correspond to each other. This fender better correspond to the real fender in real life, the angles on that. Make sense? But the corresponding sides, they cannot be the same as each other. They just be what we call proportional to each other. So like here in real life, let's say that's 400 miles in real life. The border is just about 400 miles. There is absolutely no way that your map that's going to be 400 miles long, and et cetera, et cetera, et cetera. There's a scale factor involved. If you go to our model car, I know it's hard to read, but you see this 1 to 25 right there? There's a scale factor. What does that mean? That how many times bigger is the real car compared to this model car if it's a 1 to 25 scale factor? It's 25 times larger. So this tire right here is 25 times smaller than the real life tire, right? All the exact same measurements, but they just took a 25th of that, right? This windshield is 25 times smaller than that windshield, and et cetera. And obviously, on a map that there's some sort of scale factor. They say 1 inch equals so many miles or something like that. There's a scale factor involved. So to be similar, there are two rules. Let's write those two rules at the top of our practice sheet, as you'll see next. That corresponding angles will be congruent to each other. So write that at the top. Two rules to be similar. All right, this whole bottom statement down here, write that at the top of your practice worksheet. Two rules to be similar. That one corresponding angle should be congruent to each other, and two corresponding sides should be proportional to each other. Both things have to happen for it to be similar. Now, I've got to warn you, if you've got a weak stomach, the next slide is probably not for you. There's some very ugly things on the next page. So just be careful, but watch out. Ah! That's scary. Right? They want to know if Mr. Dreyer's picture from the left to the right is similar to each other. Well, there's two rules. Number one, that the corresponding angles have to be congruent, correct? Now, it's not all these crazy angles in his face. It's the overall shape is a picture, right? Take a wild guess what you would estimate that angle to be right there. 90, 90, 90, 90. Is it 90, 90, 90, 90 in this picture also? Yes or no? So all the corresponding angles are congruent. Are the corresponding sides in proportion with each other? Well, this side right here is 8 inches, and doesn't it correspond with this side right here, which is 4 inches? What's the scale factor back and forth? 8 over 4, right? Which reduces to what? 8 over 4 doesn't reduce to a half. What's 2 to 1? Isn't that a 2 to 1 ratio? This is twice as big as that, correct? Is that the same proportion here? If I went 8 over 4 this time, don't I have to go 6 over 12 this time also, right, to keep it in the right proportion, just like vanilla over eggs? Better equal vanilla over eggs. Are you with me on that? Do you get 2 over 1 when you do 6 over 12? No, that is not proportional. And these days, you probably did a little bit of photoshopping or have experience with that, as you know that if you wanted to take this picture right here, to keep it proportional, you should drag the cool corner thing, which changes the length and the width by the same amount. If you don't, if you only drag one thing, it stretches it, and then the gap between the teeth gets wider and wider and wider and wider. So, not proportional. What do you think about that one? That's way better looking than Mr. Dreyer right there. Is Ms. Maska similar? Well, obviously, rectangular will assume 4 right angles, 4 right angles. Are we okay with that? Scale factor, 8 inches to 4 inches. What's the scale factor? Big over little. What do you got? 2 to 1? Is this a 2 to 1 ratio also? Those pictures are similar to each other because of those two rules. The corresponding angles were congruent, and the corresponding sides were in the same proportion each time. Sound all right? So, here we go with similar polygons. Okay, you got those two rules at the top. Here's the interesting thing. You've seen this symbol before, right? What's that symbol mean? That means congruent. Now look at this symbol. Isn't that just the squiggly part of it? This symbol means similar to each other. That thing means that they are similar. So they're telling us right here that ABCDE is similar to PQRST. That's called a similarity statement right there. This is a statement that states these two things are similar. Ladies, gentlemen, I've been doing this for a long, long time. There is one trick to these similar polygons / similar triangles that makes it the easiest problem in the world to deal with. Can you recognize the two guys right here? There's two different polygons. If they're similar, they're probably not going to be the same size, but they're going to be the same shape. Can you tell me which one's big and which one's little? Where's the big one, on the left or on the right? Put a giant B in that one. B stands for big. This would be the little polygon then. Put an L in there. It seems so elementary to do that B and L for big and little, but it saves lives. That little bit of a step right there makes everything work out just perfect. But that's really the basics behind it. What we're going to do today is find the missing side lengths and etc. So first thing is, I know they're similar. How did I know they were similar in the first place? Can you help me? They told me so right here. Then I bigged and littled it. Cool? And here's what we do. We're going to do the same thing as a class every time. Every scale factor that you find for me will be big over little. Everyone got that? We always do big over little. So here's the thing. I need to find the scale factor between these two polygons. Here's what you need. You need to find two sides where you know both their lengths already, but they correspond to each other. So find two sides that correspond to each other, and you know both their lengths. Study that with Pal real quick. Find two sides of this polygon that correspond to each other, and you know both their lengths. So check this out. Here's a 12, right? What corresponds to this 12 in the other polygon? This. Do I know both their lengths? Yes or no? Nope, so that doesn't work for me. Here's an 18. What corresponds to that in the other polygon? Do I know both their lengths? Nope. But obviously, boom and boom. Don't those guys correspond to each other, and you know both their lengths, correct? So how will I write my scale factor? Let's do this. Scale factor. I think it might say that for you below. Scale factor. Should I do 20 over 32 or 32 over 20? We're going to do 32 over 20. Why 32 over 20? Big over little. Big over little. I know that says larger over smaller. Let's just call it big over little. Does that sound all right? Big over little. So, can that reduce, though, my friends? 32 over 20. Can that reduce? What do you want to reduce it by? 2? All right. So, 2 goes into 32 how many times? How many times does 2 go into 32? Thank you. And then 2 goes into 20? That's reduced. Did I reduce it all the way? Can we reduce it by 2 again? So that would turn into what over what? 8/5. If it reduced by 2 and reduced by 2 again, what number really went into both of them? 4 did. Our scale factor is 8/5. Cool? To find missing lengths in similar polygons, we must find the scale factor first. Sound awesome? Now let's use the scale factor to solve for x. So here's x, right here. Do we know what corresponds to x in the other polygon? The 12 does, correct? So here's what you do. You set up a proportion. We know that these are proportional because they're similar, right? Aren't the corresponding sides proportional? Rock and roll. So start with your scale factor. What's our scale factor? 8/5, right? 8 over 5. Now, I want to set that equal to, if I want to solve for x, should I do x over 12 or 12 over x? Now, how come you said 12 over x? Well, how do you know that 12 is bigger than x? Because I don't even know what x is. How do you know that 12 is bigger than x? Because it's in the big polygon, and that's where this and this are helpful. Doesn't 12 have to be bigger than 8 because it's in the big polygon? So 12 over x. With me? Now, how do you solve that proportion? Cross multiply. So 8x equals 5 times 12. Isn't that 60? Correct. And then divide by 8. Does that come out nice? Yes or no? Not really. So I had a rule last time. I said, should we have a decimal or should we not have a decimal? The kind of problems we had where we did not give decimals was algebra problems. Correct? Is this an algebra problem? I think that's a geometry problem. Correct? Isn't this like trying to find a distance, find this length, all that stuff? So punch it in. What's 60 divided by 8, baby? 7.5, right? I think that 7.5 makes perfect sense for that. So let's say, hey, how long is that? What's the distance from B to A? I'd say 7.5 units, right? Instead of 15 halves units. You with me on that? This is not an algebra problem. This is a geometry problem. Cool? Let's find y. What I want you and Pal to do is set up a proportion to find your y. Here's y right there, right? See if you can set up a proportion to solve for y. Scale factor equals proportion. Here's y right there. Let's find y. My scale factor is what, my friend? 8/5, 8 over 5. And what does y correspond with in this problem? 18. Right, y'all cool with that? So should it be y over 18 or 18 over y? It has to be y over 18 because we're doing big over little, and we know y is bigger than that because it's in the big polygon. Is that cool with us? So cross multiply. 5y equals 80 and 64, 144. Is that right? Then y equals, that'll get a decimal. Does it come out nice? What'd you get? That's a nice decimal. 28.8? Or is it 28.75? 28.8. That's a nice decimal. What's not a nice? Next problem. Are these two polygons similar? Yes or no? Someone said yes. Tell me how you knew that. It tells you so right here. There's a similarity statement. Okay? Next move. They're asking you to find x, y, and z. There's a typo right here. Let's cross this guy out. This w shouldn't be there. Let's call that z. Okay, and that's a typo. They're asking us to find x, y, and z. We can do that knowing that these are similar. Cool? First thing we need. What do you think? Before scale factor. So before we even scale factor, you're right. The first thing we need is a scale factor. What's the first thing we should do? Big and little. Big and little it. Big and little it. B and L. That saves lives. Keeps your proportion all nice and balanced. Now find me a scale factor. Find two sides that correspond to each other, and you know both their lengths. We got the 30 and the 20, so that'd be 20 over 30 or 30 over 20? We're going to do big over little every time. Could you do it the other way around? Of course you could. I just want us all to do it the same way. Does that make sense? So can 30 over 20 reduce? To what? 3 over 2. Now let's find the values of x, y, and z. Let's start with x. I'll help you get started. Here's x. What does it correspond with? 21. So we'll set up our proportion. Start with the scale factor first. What's the scale factor? 3 over 2. That will be equal to, should it be x over 21 or 21 over x? Big over little, baby. Daddy likes it. 3x. What did we get for x? I guess you're still working, that's fine. Did you get 14? Then I would put it two places. I would put it here, whop, whop, in the answer blank, and then I would also go back and put it in a picture. It's just nice. If you have information and you have a picture, you should put that information in the picture. Find y and z for me, por favor. If you pause the video and to get that done. Once you have found it correctly, answer the next question. Just find their perimeters. What do we get for a perimeter of ABCD? 52. Is everyone cool with that? How do you say these? I don't remember if I've told you this. How do you say those things out loud? Not told you? Prime. A prime, B prime, C prime, D prime is what that's called. How do you find that? Or what is the perimeter of A prime, B prime, C prime, D prime? 78. Just adding up side lengths, right? Much easier to do when you put the information back in the picture, too, right? So find the ratio of their perimeters. Should we put it as 52 over 78 or 78 over 52? Big over little, right? 78 over 52. Do you think that that reduces? Yes or no? Yeah? They're both even, so we could reduce it by 2. I'll tell you what, I'll save you a lot of time. 26 goes into each one of those, right? Reduce that by a factor of 26. I'll bet you'll be super shocked of what that reduces to when you reduce it by a factor of 26. What does it reduce to? 3 over 2. What's so fabulous about 3 over 2? That was our scale factor. Now, let's see if you can hook it up for later. The ratio of the perimeters of similar polygons will be the same as the scale factor every single time. You don't need to find the perimeters to answer that question. I'd like to repeat that. You don't need to find the perimeters to find the ratio of their perimeters. If they're similar, which they are, the ratio of the perimeters will be the same as the scale factor. Now let's take it a step and beyond. What if I asked you to find the ratio of their areas? I don't even know how to find the area of that shape, right? It's a quadrilateral, correct? It does have an area. There's some space inside, but what would be the ratio of the areas of those? I don't need to know their areas to figure it out. Are they similar? Yes or no? Do I know the scale factor? Now, all you need to know is the label that should be an area. Is it units, units squared, or units cubed? It's square units, right? Is an area in square units, correct? So all you have to do is take the old scale factor of 3/2 and square it. Cool? Now, those of you that are too calculator dependent, you need to understand how to square a fraction. Does anybody in here know what 3 squared is? Does anybody know what 2 squared is? So you just square each number. What's 3/2 squared turn out to be? So if I asked you what's the ratio of those guys' areas, since the scale factor is 3/2 and area is in square units, that would be 9/4 the ratio of their areas. Now let's pretend they were three-dimensional shapes, which they're not, but let's pretend. What would be the ratio of their volumes? What kind of label do you put on volume? Cubic. So you take the scale factor and you cube it, and 3 cubed is 27, and 2 cubed, what's 2 cubed? What's 2 times 2 times 2? What's 2 cubed? 8. The ratio of their volumes is 27 over 8. They're going to ask you some tricky questions, and maybe you've even seen some of those on the STAR test before. It's like, these are similar to each other. What's the ratio of these guys? It's perimeters. What label goes on perimeters? First power, second power, third power? First power. That's why we got 3 halves. Areas. What label is area? Squared. And volume is third power, correct? So all you got to do is do that to this.
All right, so these guys are similar. We'll totally start with helping ourselves out with the big and the little, and we need to find the scale factor. We'll find two sides that correspond to each other, and we know both their lengths. Looks like these. We'll write that guy as big over little, and that can reduce to be 5 halves, so nice. And then find x. X is right here. He corresponds, let's use blue, he corresponds with this 35. So we'll set up our scale factor of 5 over 2. And remember, we want to do big over little, so we'll do 35 over x, because 35 is in the big polygon, and we'll cross multiply. So 5x equals 70, and then divide. X equals 14, sorry. All right, yeah, 14. Why don't you pause the video and find y and z. Set up a proportion every time. Start with the scale factor. Y, I. Z. So when solving for y, I did a little cross multiplying, and I got 20 here. And then when you're solving for z, always make sure you cross your z's. Like, I have horrible handwriting, but you can always tell where my z's are because I crossed them in that case. So not too bad there. Then they ask if ABCD is similar to EFGH. If not, explain why. Well, guys, there's only 2 rules to be similar. We totally wrote that on the front side of our paper. The 2 rules are if corresponding angles are congruent to each other. So you can see all the angles are 90 in this. So it's like, of course, corresponding angles are going to be congruent to each other. You don't even really need to worry about that. But it's about the corresponding sides being proportional. So this dude right here, this 5, corresponds with this. And if we did a scale factor, you get 5 over 2. Well, you have to get the same scale factor back every time for them to be proportional, or to be similar, and to be proportional, whatever you want to say it. This is a scale factor of 5 over 4, so these are not similar. There's no way that they're similar. So the reason, it's real simple, is because out of the 2 rules that we tried, the corresponding sides are not proportional. And you can abbreviate just like I did right here. You know, it's whatever. But you test the 2 rules, and whichever one fails, that's your reason why. If they both pass, then, dude, they got to be similar to each other. All right, last one, a little tougher, right? They say these guys are similar, so let's start with a big and a little, and we need to find the scale factor first. So let's find 2 sides that correspond to each other, and we know both their lengths. So kind of looks like these, but we probably better double check that with our similarity statement. Does segment AB correspond to segment DE? And that's a yes. They do correspond to each other. So our scale factor will go big over little is 20 over 12, which that can reduce to 10 over 6, and that could still reduce to 5 over 3. So 5 over 3 is our scale factor. Then, making the x, the y's, and the z's. Let's go try those out. Let's find x. Whoa, that's different. X is an angle measure. We don't need a proportion to find an angle measure because the corresponding angles are congruent to each other in similar figures. So since this is an angle F, I can go back up here to my similarity statement and see here's angle F. Doesn't he correspond with angle C? So that's this guy. Don't know him. Well, maybe we can figure him out. This one's 90, this one's 60, and that have to be 30 degrees right here. And since these are supposed to be exactly the same, that's going to be 30 degrees. So that was different. Then finding y. Y is the side length. Nice. He's the hypotenuse. He'll correspond with the other hypotenuse. So let's set up a proportion for that. Scale factor is 5/3. And that'll be 40 over y, big over little. Cross multiply. And then we'll punch that in. 120 divided by the Cinco. It's 24. So nice. And then the last one, it's got that weird radical in it. And we did this on purpose because there's some on your homework like that. We don't want you to get scared. Z is a side length, and he's on the big side. We'll do it over little. We're just going to treat a radical like it's a variable. So that radical is just going to tag along for the ride. When I cross multiply, like if I want to multiply these together, it's just like saying 5 times 12x. You just take the 5 times the 12 and let the x come along. So 5 times 12 radical 3, you multiply the 5 and the 12 and you get 60, but the radical 3 just comes along with it. That'll equal 3 times z. And same thing when you're dividing. I'll go old school and do baby steps. Like all you end up doing is you say, hey man, I need to take the 60 divided by the 3 and I'll get a 20, and that radical 3 just comes along for the ride. So it looks scary, but don't be punching that in to change it to a decimal or anything. Just keep that thing coming along. Alright, let us know if you have questions. Have a good one.